Good afternoon or morning, everyone, and welcome to our first iteration of the Hazardous Weather Testbed Experimental Warning Program Satellite and Radar Convective Applications Experiment. I am Elisa Bates from the Weather Warning Decision Training Division, and with us today we have 6 forecasters from all across the country, and they will be telling you about the experimental products that, and some experimental, some are operational products that they've used this week. And now I will turn it over to one of the principal investigators on this project. He is a University of Oklahoma sim scientist who works with the SPC. So go ahead, Michael Bolin. Thank you very much for those briefings. So last but not least, we will be talking about the Geostationary Lightning Mapper, or GLM products. And for that, we have Michael Charnick from the WFO in Grand Junction, Colorado.
All right, so one of the things we got to look at this week was a variety of new GLM products that we don't currently see in AWEPs. Right now, most of the field is familiar with using flash extent density. That's what you see on the top left of this 4-panel right here. The other 3 images are event density, average flash area, and total optical energy. These are the 3 that I think amongst the group we found to be fairly useful out of the new suite of products. Event density takes a little bit closer look at the actual events that make up the flashes in GLM. And one thing that we noticed here, this is a case of a supercell, a splitting supercell in central Texas. You can actually notice a second core of higher lightning activity as this cell spreads out and the splitter moves off to the north and the east. That signal is a little bit more muted in some of the flash extent density products that we're used to seeing. So this could be, this has some implications for use in storm intensification, possible storm splits, sort of high resolution data that you need to see that. Over here we have average flash area. This has potential use, again, for storm intensification and weakening. Usually when you have a developing thunderstorm, your lightning activity, the total lightning values, the lightning is shorter in length. So you have a smaller average flash area right near the core of those thunderstorms. And as the thunderstorm spreads out, the anvil spreads out and weakens, you get sort of longer flash events here. And what you're actually seeing is that average flash area increase as the thunderstorm grows and ages. So not really sure right now what the applications of this could be, but it definitely seems like there's some potential with this product. And finally over here we have total optical energy. This product has a lot of potential uses in initial stages of thunderstorm development, where the updraft has a lot of optical detection from the satellite. You can really see that thunderstorm develop well. Another thing that we found over the course of the week is that layering reflectivity on a GLM image is useful, especially if you're only masking out sort of the lower reflectivities and keeping the cores displayed. This sort of allows you to see what the core is doing as the lightning data is evolving as well. So it's sort of a kind of a best practice that we've taken away from this week as well. This is another instance, a different supercell later in the day. This is just showing the event density as well as Earth Network's cloud-to-ground strikes. So in this case, you see a strong thunderstorm develop. The event density really picks up in intensity. But you see something interesting happen right around here. When that cell finally is done splitting and it starts to right move and dive to the south, the cell reaches its peak intensity. And right at that point, you also lose some of the event density lightning signal. So something we were introduced to this week is the fact that optical extinction could play a role in GLM data. Even though there's a lot of strikes still showing up here on the Earth Network's ground detection, the total lightning from the satellite actually decreases, which is kind of an odd signal. So this has some impacts possibly for storm intensity signals like that down the road. So some takeaways. Flash extent density is more descriptive. When cells split, you can see double peak signatures early in the data. Average flash area could have a use in core formation of thunderstorms and other possible impacts there. GLM event density was more informative at times than other GLM data forms for this supercell. Intense deep updraft cores may result in some optical extinction, as we saw with the second example. and event density values decrease around when the storm peaks in strength due to that optical extinction. And I'll just make one note. We were looking at some cases outside of the plains too, just in sort of areas that the convection was not as intense. And some of these trends were also noted. So offices out west that aren't getting big supercells, don't worry, we're looking at you too, and the lighting data is definitely useful out there as well.